So this is the session number. This is the 20th such session that we are conducting, and I welcome all of you to today's session. So let us start taking queries that we have been asked. So first I'll take queries from the Google form, and then we'll take queries from the live comments. So this first query has been asked by Mr. Devlin. He's from Oman and he's a working professional. And let me just copy what he's asking. So he has shared one image in WhatsApp. Let me just take that image also. And let me take you to OneNote. Yeah. So this is his image. He's asking, I have a box frame. Here the bottom straight member is resting on floor and columns are placed above the bottom member. So what type of support should I make it instead? Also, how can I assign it to bottom member? So I think he has a bottom member over here, which he is specifying. This is his bottom member. And on top of this bottom member, they have a vertical member like this. So this is their vertical. So he's asking how to model this thing. And the bottom straight member is resting on the floor. Columns are placed above the bottom member. So what type of support should I make it instead? So one way to do this could be that, mm, let's say I'm just thinking how you could approach. So one way could be that you model and then take these and then have small support like this. Okay, so what I can suggest over here is that now it depends whether your bottom member is going to be loaded or not. So one of the ways could be that this is your vertical member, this is your node, this is your horizontal member, this is again vertical. Okay, these are your verticals. Right now and these are your horizontal members. Then what you do is you just have a small little projection like this. Okay, this property can be, I don't know what property should you provide over here, because in actual you have something like this. So the bottom member is resting on your RCC pedestal, right? But providing support over there may not be possible. So I think here sort of projection you can take below. You provide support over here, but then what property you should assign to this small little stool type of member? What property to assign here? That's what I'm thinking. That what could you do over here? Any suggestions? Mm. So I think in this case, I'm also thinking what can be a possible way to provide a property over here, or what property should I provide? Should I provide the column property, because that may not be the ideal way, because the horizontal member is resting. Now this will also, okay, this will also, see, here you also need to understand whether this horizontal member is going to be loaded or not. So is it going to be loaded, or is it going to be completely rested on ground even though it's loaded? you just first see whether it is going to be completely rested on ground or not. If it is completely rested, I would say that no need to even model this horizontal member. Then you could locally do the checking. Okay, Mr. Devlin is informing it is loaded, but it is completely resting on ground, right? Although it's loaded, it is fully rested on the ground. So its own bending moment can be ignored. Yeah. So I would say that assuming that the ground is rigid and this is completely in contact, that horizontal member is completely in contact with ground, you could ignore the bending of this horizontal member. So you could even ignore this member from your model. You could even ignore your member from model. Okay. And this portion, which is common to, let's say, both the horizontal and vertical, this portion which is common to both horizontal and vertical, this also for the timing you could ignore, and you could just take the columns and provide support to your column point, and maybe locally check this intersection, this intersecting zone where your top member, vertical member, is resting on horizontal. You locally check it for the shear transfers. So any local buckling or any local crippling is taking place over here where this vertical member and where this horizontal member are intersecting. So load transfer is happening through this horizontal cross section. So you could locally check these for local buckling and crippling manually, maybe. Okay, you could locally check it for local buckling and crippling manually. Another way could be Another way could be that you model your. So one way is to ignore that horizontal member completely. Don't worry about it. Another way could be that you model it like this. So this is your vertical. This is your horizontal. You model it like this, and all throughout, you provide some very stiff, very very stiff spring support, like supporting system in the software. So very very stiff. Why very very stiff? Because it is resting on ground, which can be assumed to be of a very high stiffness. So very very stiff spring supports you could assign to this entire bottom member at the node points, also at the member points also. Mr. Devlin is saying, but the complete frame is subjected to lifting with crane also. See, that lifting thing then is a different scenario. Then you try to make two models. One will be your lifting model. In the lifting case, you can just model it like this. So in the lifting scenario, you can model it like this, and then whatever are the lifting points over there, you can apply those reactions from whichever points the lifting is going to happen. So lifting case model you could prepare separately, and the model when it is resting on ground, when you need to check the stability, you could model it this way by assigning very very stiff spring support. Or the second option I have given is to completely forget the horizontal member and do the checks for horizontal member separately. So this is what you could do. All right, these are my suggestions. Okay, the next question is from Mr. Kundan. He is joining us from Nagpur. He is asking, when should we take temperature stresses seriously if truss length is 45 meters? So when should we take temperature stresses seriously? If truss length is less than 45 meters, can we ignore it? If both ends support are assigned, pinned, and executed same on site. See, you must understand that if you have a truss system like this, okay, and if this assembly is is, let's say, having some pin roller arrangement. How do we execute a roller arrangement on site? By actual practice, we provide slotted holes, or you can go for actual pin roller assembly if you can provide it. But providing actual rollers is very difficult in small projects, and it is difficult to fabricate and do the installation on site. So usually what we do is that, if I show you the plan view of my base plate, this is the green is the base plate. We will have, and usually you have two plates, one is the bottom plate, one is the top plate. So in the top plate you provide slotted holes in the direction of possible translation, and the length of the slotted hole is calculated on the basis of the expected translation. So this is your top plate. So you, and then there will be a bottom plate also. In the bottom plate, so black is the bottom plate, let's say, green is the top plate, and here is your RCC pedestal, red, and you have your anchor bolts, purple are the bolts, or let me use some other color. These pink are the bolts. So what happens? The bolts over here, they are fixed in concrete, and they are integrally connected to the black plate also. Not connected means there is no translational freedom that is available in the black plate. So these bolts are free to translate. Only this green plate is free to translate, I would say, because of the slotted holes. So one way is to have this kind of a roller assembly provided, and this can be approximated as a roller assembly. On the pin side, you will have no slots in the bottom plate or top plate. So if you provide system like this, what will happen, that when there will be temperature related stresses, or even stresses related to gravity loads, if there is any translation, that is taken care by the, sorry, if there is any if there is any translation, that translation can be accommodated due to presence of these slotted holes. So because of this, you will see that the moments, localized moments in these members, and localized heavy axial forces in the end members is prevented. What happens if you have a pin assembly and translation is restrained? You will have high axial force in these end members, and in these end members, because the depth is also less, depth of the truss is also less, you will get concentrated heavy axial forces, and because of that, your truss members will become, you will have to provide larger cross section truss end members. So if you want to avoid that, you can have a pin roller assembly. So now his question is, when should we take temperature stresses seriously? See, so it does not depend on the span, it will depend on what type of exposure condition you have. So if your truss system is exposed to your environment, directly exposed to sun, then if there is no sheeting, then you should take the temperature stresses. It does not matter whether your truss is 45 meters or 25 meters or 20 meters, you should take the temperature stresses even for small span trusses, provided it is exposed to sun. If you are covering it with sheeting, the sheeting is able to provide some degree of insulation. Although you may not be providing separate insulation system, still your sheeting also, presence of your sheeting itself can uh, can reduce the exposure, and the temperature stresses may not be that important. So short answer is that you have to take temperature stresses. It does not depend on the span. The magnitude of temperature stresses can vary with span, but as a designer, you should consider it. So I'm not saying you ignore it. Okay. So you have to consider it, and then as per your end conditions, your member forces will be generated, and for that you need to include it in your design. All right. Okay. Mr. Rohit Kashyap is asking, where do we apply temperature loads in RCC? only tension member or compression member as well. What about slabs? So in RCC beam columns, let's say you could apply axial temperature stresses. That means temperature stresses which are going to cause elongation or shortening. So you could use software where uh, you should use software and use the option where axial elongation or axial contraction uh, is assigned to your beams or columns. For slabs, generally the temperature differential will be across the depth of your slab. So if this is my slab, this is the top surface, this is the bottom surface. So temperature differential is across this depth. Across this depth is your temperature differential. So if you want to assign temperature stresses to slabs, there is this option in the software to apply it across the depth of your member. Okay, so you could do that. All right. So this was Mr. Kundan asking question about when to consider temperature stresses. Moving on to next question from Mr. Balaji. He is joining us from Chennai, and he's asking. His question is, "Hi, can you touch upon base shear and story shear in ETABS with respect to 1893?" No, you have to ask specific questions. What is the doubt you have related to this? What is your doubt related to this? Base shear is this total summation of story shear forces. So basically, earthquake is an inertial force. There is no actual force acting as such. It's a pseudo force that we assume. So what's happening that the total inertial force is the base shear. Base shear is the total inertial force that the structure will experience because it is unable to move with the earth, or it is offering resistance. It's not uh, it's not moving with the earth, it is offering resistance. So base shear is the total inertial force. And then what we do is that we say that, let's say this is my base shear. Now we say that, assuming that a pseudo force was applied at every level which would give the same behavior, or the summation of which would give you the same value as your base shear. In that way we distribute uh, the base shear to story level forces. These are pseudo forces. That means no actual force is hitting, no actual force is acting on these story levels. Okay, it's an imaginary pseudo force that we are assuming, so that the summation of this, the summation of all these forces should be equal to the base shear. So I could say the base shear is the inertial force. Then we are dividing it or distributing it to all the story levels, and these are imaginary forces or pseudo forces. So what we are distributing at story levels, we are calling it as story level forces. Okay, summing them up will give you the total base shear. All right. Okay. Mr. Salman Roj is asking, related to the last discussion that we had, in which region we need temperature load. No, this question is not appropriate. In which region we need a temperature load is not an appropriate question. You should ask in which conditions or under which conditions temperature load is critical. So wherever your delta temperature, the max temperature over the ambient, or the minimum temperature over the ambient is of a higher magnitude, the temperature stresses become critical over there. So those depend on your geographical location. So you go to IS 875 part 5. Over there you will see isotherms given for maximum temperature and minimum temperature at a location. They have given map of India and they have given locations, isotherms. So from there you find out this delta, or I should say temperature. Instead of writing delta, I should write T max minus T ambient and T ambient minus T min. This will give you the deltas. So higher is this temperature difference, higher is the temperature load. Okay, all right. So this was related to story shear and base shear. For you can write, sorry, you can write down if you have any specific query related to it. Next question is from Rohit Kashyap. He is joining us from Guwahati. He is saying, I have a large hospital building. It has been broken down into six parts with expansion joint. When we are trying to work in SAFE, we are importing all these parts into one model. When we are making the pile caps and analyzing the foundation, the reaction coming in piles are not proper in spec X, spec Y. If we check the model separately, it's okay. Let's say separately spec X is 100 each, so total should be 200. But after combining, it's coming over 400. Why is this happening and how to take care of this problem? I would say for footing design, instead of using spec X, spec Y, because there will also be a problem of loss sign. So instead of using spec X, spec Y, because you are not sure how the internal combination of different model outputs the software is doing. So my suggestion would be to go for equivalent static reactions instead of using spec X, spec Y, or response spectrum cases for foundation design. Go for equivalent static load cases for your foundation design. That would be my suggestion. It may be slightly conservative. So if it's because the base shears are not scaled, base shear for response spectrum load cases usually comes out to be lesser than the base shear for equivalent static. So what you can do is that my suggestion would be, instead of going for spec X, spec Y, or response spectrum cases, I would suggest for raft design, you go ahead with equivalent static. That would be my suggestion. If you go with equivalent static, your combinations you don't have to bother, and you will be saved from detailed mathematical combinations that software do based on dynamics for different model cases. So you will be saved from that issue, and equivalent static will be much more easier to combine. So this would be my suggestion to you. Mr. Shailesh is asking, adding over here, in this case, can we convert in ETABS? What do you want to convert, and to what you want to convert? Mr. Shailesh Gupta is saying we can convert spec to linear static with story shear can be applied on diaphragm forces in ETABS linearly. No, but you will convert the response spectrum cases how? Because ETABS is going to give you different nodal diaphragm forces for different mode shapes or for different modes. So how are you going to combine those model outputs and apply it in equivalent static? How will you do that? ETABS is not giving you a single output. It will give you the diaphragm forces for different modes. So how are you going to combine those outputs? No, if you go to ETABS and if you try to see the diaphragm forces, it does not give you any diaphragm force for RS case. Does it give you? It gives you for the individual modes. It gives you the diaphragm forces for individual modes, not for the RS case. And then again, there will be problem that a particular mode may be more critical for some of the story, so you never know what's happening. My suggestion would be to not make it more complicated. It is always better to take the equivalent static cases and then just use it for your foundation design. If it is coming out to be conservative, because although as I just said that the base shears will be scaled, but still the overturning moment due to equivalent static will be higher than the overturning moment due to response spectrum case, which will make your foundation design more conservative. You can use some scale factor to slightly reduce the equivalent static base shear. That is what you can do. Okay, but use equivalent static load cases. So I'll just write go for equivalent static load case, and you may use some reduction factor. You will have to calculate that. You may use a reduction factor to reduce the equivalent static overturning moment, to reduce the overturning moment due to overturning moment at the base, overturning moment at the base due to equivalent static. You you may want to reduce this overturning moment due to equivalent static to match with overturning moment at base for the RS case. So that means you could multiply this equivalent static load case by some reduction factor, maybe something 0.7, let's say, whatever factor comes out. So 0.7 EQ. So this type of load case you can prepare and then bring it to your safe. So that would be my suggestion. Okay. So these were the questions asked on the Google in the Google form. Now let us take the questions in the YouTube comments. So Mr. Dhanush Raj is asking minimum load combinations to be considered for member design. I have seen people take only max and min AF. What is AF? Max M3. Acha M3. Max resultant shear force. No, that's wrong. You should be using the envelope procedure. You should be using the envelope procedure. Yeah, you should be using envelope procedure, especially where compression and bending actions are going to interact with each other. Over there you should be using the envelope procedure. So I would say wherever bending, compression interact with each other, for whichever member design bending and compression interact with each other, use the envelope procedure. Oh, sorry, don't use the envelope procedure. Don't use the envelope procedure. Design for individual load combinations. Design for individual load combinations. So for columns, for footings, your compression, okay, and bending moments interact with each other. So that's how the interaction diagram for column design is prepared, let's say. Or if you are having a steel member, that's how the interaction ratios are calculated. So they include the effect of both compression, bending in them. So for such member design, you should not design for envelope, you should design for individual load combinations. So for example, you have 10 different load combinations. You design your member for those 10 different load combinations, and whichever is the worst output, let's say if you are doing RCC design, whatever is the worst reinforcement, or if you are doing steel design, whatever is the worst utilization ratio, that is the governing or critical value for you, okay, or critical load combination for you, let's say. So this max thing should can only be taken where the two forces are not interacting with each other. So for example, bending and shear. Okay. So when we design for bending, usually it does not interact with the shear. Or when we design for shear, it does not interact with bending usually. It does not affect the design, so to say. So in, let's say you are doing an RCC beam, the design for shear is not interacting with design for bending. In that case, you may use the enveloping values. But wherever there is interaction between individual forces, you should not use the envelope procedure. You should use the individual load combinations for design. Is that clear? Okay. Mr. Dhanush Raj is saying, please elaborate how to select these combinations, thereby avoiding importing all load combinations. No, so you could save yourselves by designing it three times. Maybe you could save yourselves by designing it only three times. So, for example, you are designing a column, and your column is to be okay. So his question was regarding connection design. So even for connection design, let's say you are designing a beam column connection, steel beam steel column connection. Now in that connection also, so let's say this is your column in elevation, and this is your beam in elevation, and you have this connection, whatever. Now this connection also, so let's say it has moment, shear, and axial force. Now in this case, what's happening? All these three are going to interact, and the effect of all these three is going to govern the connection design. So you should not take the enveloping values over here. Instead, what you should do, at least you take a load combination where the moment is maximum, wherever the moment is maximum, and for that load combination where you are, let's say, getting the moment maximum, you take whatever shear and axial force value you have. Then you choose another load, then you pick up another load combination where the shear is maximum, and for that load combination you take the corresponding moments and axial forces. You take another load combination, then third combination where the axial forces are maximum, and for that load combination only you take the corresponding moments and shears. So in this manner you check your connection design three times. Whatever is the worst case output, you provide that. Okay. All right. So this was his question. Then Mr. Magaj is asking how to design piles for lateral loads for a tall building, as there are number of piles. So we have to design each pile for lateral load. Yeah, so you will have to model those piles in your model. Okay, you will have to model your piles. So suppose you had a tall building, and suppose you are providing a raft, pile raft system. So let's say you have a raft provided below, and you have piles over here, raft plus pile, let's say. So first of all, through the model, you find out the individual lateral loads in the pile, and then for each lateral load, obviously you're not going to design the pile separately. So you could just pick up the worst or the greatest magnitude of lateral load, and for that you check the pile, find out the depth of fixity of the pile, and then design the pile accordingly for lateral load. Okay. Yeah. So do not design each pile for lateral load. You could just pick up the worst lateral load coming in the pile, design for it. I would not suggest you to check each and every pile individually. It does not make sense. Okay. All right. Then Mr. Magaj is asking why joint reactions and axial forces do not match. No, they should match. I don't know what you are doing. They should match. They will match. Joint reaction at the base, and let's say the column axial load over there will match. See, it's quite possible that you have other members merging, or you have other members connected to that joint. So then you will have to take the component so that the reaction is found out. So in that scenario, your reactions and axial forces may not match. But if you have a single member, and uh, that single member has a support point, then the axial force and reactions will match. Okay. Then Mr. Pavan Patil is asking if strata present is very hard, rocky strata at very low depth from natural ground at 2 feet. In such situations, can we place footing at surface level? Any additional parameter to consider? There is this code, I am forgetting the name, which tells you about the minimum embedment depth. Okay, which tells you about the minimum embedment depth. So you may have to follow that. So even though your hard strata is present, let's say at 600 only, and he is asking, can I just put my footing over here? So it there is a I am forgetting which code gives it, but about minimum embedment depth, there is a clause given. So you may have to follow that provision. Otherwise, it's okay to provide your footing at even shallower depths if the bearing capacity, sufficient bearing capacity is achieved over there. Or if your strata is such that you are getting good bearing capacity of soil or rock, whatever, you may provide or you may rest your footing at that level also. But there is a codal provision which gives you the minimum embedment depth. You may have to follow that. Okay, right. Then Mr. Magaj is asking, it is observed that if column is attached with retaining wall, the axial forces of column at retaining wall levels reduce as compared to above floor. Yeah, because your retaining wall is quite stiff, so it attracts more axial forces in it. So it's expected to get such a thing because your retaining wall is much more stiff. It is attracting forces. Mr. Magaj is continuing with his earlier question about the joint reactions not matching. No, you share a screenshot or share any specific condition. Okay. Yeah. Then we have question from engineer Shailesh Gupta. He is saying in safe while designing raft with lateral loads in area spring only vertical stiffness can be provided, not lateral springs. How to analyze for lateral? In safe while designing raft with lateral loads. No, so why do you want to design your raft for lateral forces? If your raft has pile, then you check for lateral forces. But if your raft is only raft, why do you want to design it for lateral forces? See, anyway, it's not going to go anywhere. Your raft is such a large mass that's not going to slide anywhere or it's not going to translate anywhere. So why do you want to analyze your raft for lateral forces? And your raft is so large that in plane bending or in plane shear forces will be non-existent or so negligible that you may not be bothered with it. So no need to design your raft for lateral forces. If it's a raft plus pile system, then you may check your piles for lateral forces because piles may not have the good lateral capacity. But otherwise, if it's only a raft system, it's only a raft. Why do you want to check your raft for lateral? Makes no sense. Mr. Shailesh is saying in safe, raft displacement goes much more in lateral direction. So you just assign some translation supports to 4 5 corners. You just assign translational supports to your raft at 4 corners, let's say, and it is justified because your raft is not going to translate anyway. Okay, your loads are so high in dead load that the friction is sufficient enough to resist the lateral forces, so it's not going to go anywhere as such. So you can assign point or spring stiffness to your node points and assign lateral restraints over there. Not even spring supports, I would say just assign lateral restraints in X and Y, let's say, to your raft corners. Okay. Yeah. Translational restraint. Okay. Okay. Anything else? Anything else? Okay. So I think there are no more questions. So we have taken all the questions that were asked on the Google form, and we have also taken up questions from the comments. There is no question on the email. So I guess that's it for this episode. We'll meet you next time. Okay, Mr. Dhanush is asking tension not considered also. There can be load combinations which has second largest force, which has the second largest force when considered with its corresponding forces that gives governing interaction. It's rare to have that situation, what you're saying. You're saying the second largest force. So he's saying that in this case, the second largest force with its corresponding other member forces for a particular load combination is more critical. It's not very common to see that. So if you have such a case, then you better what you do is first you just study the member forces. Maybe you could use the Excel. So you paste all your data in the Excel sheet. You do sorting on the basis of values, or you could just use filter command to see what are the forces you are getting. So for example, what is the maximum force, tension force you are getting? For that, what is the corresponding moment and shear? You just see that. Also investigate what is the second largest tension. For that, what is the shear and moment? You may have to investigate it and make a sense of it before rushing to software. If you're doing it in software, then software anyway will do it for run your analysis and design for 50 different load combinations and give you the worst possible UR. So in that case, you may have to bring all the possible load combinations to your connection design software and then do the analysis design. Or you just investigate and study the outputs for different load combinations on your own and then decide what to do. Okay. Okay. So I think that's all we have for this week. Thank you for joining. And now we will see you next weekend. Same Sunday morning. I think it's working well. Sunday mornings are better than Saturday evenings. So we will have next session on next Sunday morning. You could put your queries in the same Google form. The same link is valid. So you could keep putting on your queries during the week also. No need to wait till Sunday to put your queries. So you could keep putting on your queries and we will take them up once every week on Sunday morning. So I just shared the Google form link in the comments. Keep putting your queries during the week also. Okay. All right. That's all we have for this week. Thank you. Bye bye.